Nowadays, in railway field, these spring steels are common used for manufacturing rail clips are 38C7 to EN10089, SUP10, C6150, BS970-2 A251-58, 60C2MN to GB/21222. Comparing these spring steel by chemical compositions, and the effects of these elements to the heat treatment and performance of rail clips, here we made below analysis. From above spring steel's chemical composition, we could easily find out the big difference among these steels are at content of carbon, silicon, small difference at content of phosphorus and sulfur. Based on these difference, this article analyses the effects to rail clips of different content of elements. Carbon is a most important element for spring steel. The higher content of carbon in steel could help to strengthen hardness. It plays as a role of solution strengthening in the process of carbon dissolution into steel. Therefore, carbon is a main strengthen element. Normally, the strengthen of carbon is about 5 times of silicon at quench and temper, 9 times of chrome and 18 times of manganese. According to analysis, carbon is also the most important element which affects anti-spring and anti-vibration, in order to make sure the hardness, strength, elasticity and fatigue life. Thence, carbon content of spring steels in different countries is adjusted to 0.50 Wt% mostly. However, recently there is analysis saying, high carbon content of spring steel helps increasing strength, hardness of rail clips, but it weakens the ductility, decolonization sensitivity and formation. Such like steel type CNISOMOV series, when carbon content is more than 0.5 Wt%, ductility and yield strength will decrease rapidly. In order to increase the ductility of rail clips, the trend is to lower carbon content. Nowadays, lower carbon content was taken into standards. There are SUP10, 0.47 to 0.55 Wt%. In Japan, C6150, 0.48 to 0.53 Wt%. In USA. In Germany, most of spring steels are low carbon content. The lowest one is 38C7, 0.35 to 0.42 Wt%. Most common used one is 50CrV4, with carbon content of 0.47 to 0.55 Wt%, or in France, spring steel 46S7, carbon content 0.43 to 0.49 Wt%. 45C4 with carbon content 0.41 to 0.48 Wt%. Some new developing spring steels even have less carbon content. In China, now low carbon martensite spring steel with carbon content about 0.30 Wt%, like 28 cmnb, 35 cmnb. Because of low carbon content, after heat treatment, low carbon belt martensite could be obtained. The ductility will be much better. For rail clips, when hardness and clamping force is up to specifications of working condition, the better ductility, the better fatigue life will be.